Now I'm going to talk about display pixel density, which is a similar concept to image pixel density. Just as with display pixel dimensions, display pixel density is often referred to as display resolution. But this is confusing. The pixel density is only half the story. A display may have a high density of 400 pixels per inch, but that says nothing about the pixel dimensions. A large image may not be fully displayed without adequate pixel dimensions. Imagine seeing a 4200 by 5700 image on an old 1600 by 900 monitor. Those pixels are going to have to be squeezed onto that screen, which degrades the image. Just like in the case of image resolution, display resolution is an overarching characterization of the degree to which the display can render fine detail. That depends on both the pixel density and the pixel dimensions. Like image pixel density, display pixel density is measured by pixels per inch, or PPI. The concept of retina display introduced by Apple is based on the premise that a screen should have sufficient pixel density that the human eye can't see the individual pixels at a normal viewing distance. This threshold varies depending on the device and its typical viewing distance. For most applications, especially in high-quality consumer electronics, achieving a pixel density that prevents the visibility of individual pixels at typical viewing distances is the goal. The modern standard for pixel density in displays varies widely depending on the type of device and its intended use. Here's a general overview. Smartphones tend to have the highest pixel densities, ranging from about 300 to over 500 ppi. High-end models often feature densities closer to or exceeding 400 ppi, with some even reaching up to 800 ppi in devices like Sony Xperia models that boast 4K screens. Tablets typically have a pixel density ranging from about 200 to 300 ppi. For example, Apple's iPad models range from about 264 ppi for the iPad Air and iPad Mini to 326 ppi for the iPad Mini with a Retina display. For standard computer monitors, pixel density is usually lower than that of smartphones and tablets, typically ranging from between 90 and 150 ppi. However, with the rise of 4K and 5K monitors, densities are increasing. For instance, a 27-inch 4K monitor has a pixel density of about 163 ppi. Laptop screen densities can vary widely, typically ranging from about 100 to over 200 ppi. High-resolution laptops like the MacBook Pro with a Retina display can reach densities of about 220 to 227 ppi. Televisions usually have the lowest pixel density because they are viewed from a farther distance. A 55-inch 4K TV, for example, has a pixel density of about 80 ppi. As screen technology evolves, especially with developments in OLED and micro-LED technologies, we might see even higher pixel densities become standard, especially in devices meant for virtual reality, where high PPI values are crucial to avoid the screen door effect and enhance immersion. The trend is clearly towards higher pixel densities across all types of devices, as display technology improves and customer expectations for clear, sharp images continues to rise. The best practices for display pixel density are the same as what I said in the last two slides about display pixel dimensions.